Hello everybody. Today I want to explain about a topic which I want to present it in one of the conference which I want to attend there. It's in Ostrava in Czech Republic. Now I want to present it to you now. Let's share my screen. Yeah. It is about observation the ultraviolet or UV star clusters. What is the star clusters? Star clusters are groups of stars that are physically related to each other by mutual gravitational attraction. All members of star clusters were born in the same giant molecular clouds in a few million years. Main parameters of all members of star clusters are distance, age, metallicity, and reddening. What is reddening? Maybe you ask this. Reddening is, for example, I as an observer here, and there's a star there, and between us as an observer and the star is a dust and gas. And you know that the stars have some light, as you know, or as you see here, and but that dust and gas, they absorb the light of the star, so we cannot detect or measure the light of that star directly and exactly. That we call it reddening or extinction or absorption. Open clusters are important for studying for star formation, stellar evolution, and galactic kinematics and dynamics. Characteristics of open clusters in the Milky Way: their age is less than 5 gigayears, distance from the sun is more than 45 parsec, total mass is less than 60,000 solar mass, absolute diameter is less than 25 parsec, metallicity is -1 to 0.66 compared to the sun. Mass range of the members, complete range depending on the age of the cluster. And you see here, it is somehow like our Milky Way. And the diameter of our Milky Way is 30 kiloparsec. The distance from our sun to our galactic center is 8 kiloparsec. And you see here galactic halo and galactic bulge, and most of the globular clusters are in galactic halo and galactic bulge. But open clusters are in galactic disk. And here you see the dust and gas, that they are in galactic disk. And here is our sun. Why ultraviolet? The universe that we see in visible light is quite different from the ultraviolet universe. With ultraviolet spectra, we can detect the chemical composition and the temperature and composition of hot young stars and interstellar medium, and we can detect the hot white dwarf and also the main sequence companion, which its orbit is in the orbit of a cooler star, and also evolution of galaxies. Ultraviolet photometry is range of in spectra is 200 nanometer up to 400 nanometer. But from the ground, we can detect, we can measure from 320 until 400 nanometer. And the advantage of observing in ultraviolet is our measurement won't destroy by carbon dioxide and steam. For role of ultraviolet imaging in population 1, we can identify the massive stars and the physical parameters, and also we can characterize the interstellar medium dust and resolve young stellar populations. You see here the diagram of HR diagram or Hess-Poynter diagram, color, magnitude, and here age. And you see here the main sequence, our sun is here, and the youngest cluster, NGC 2362, is the youngest and the hottest, and also the brightest cluster. And here you see the M67, which is an old cluster. It is cool, it is faint. Here you see three open clusters that we observe with the Danish telescope DK154, Danish telescope in Chile. We observed with Danish telescope and also Argentina telescope, Casleo. We observed around 250 open clusters, and most of them were new clusters. Our method is isochron fitting. With isochron, you know that isochron is not related to age, metallicity, and distance. And with ultraviolet, it is the best way of observation for reddening. Our goals are these new clusters that we observe and they are published. Are they really open clusters or not? Because some of them seems to be an open cluster, but they are somehow just a few stars, and maybe they are not separate clusters. Maybe they are from a huge open cluster, and someone just detect part of a huge cluster. But they call them different new open clusters. Also, we want to determine reddening for all of our observed clusters. With these data, a first homogeneous census of open clusters in the Milky Way by using photometric, ultraviolet photometry will be derived and compared to the literature. And these are my references. And thank you very much. Thank you for your attention and see you next time. Bye.